Sufyan and Rafia, how much we have completed in the last class? Have we completed this question or not? Just check and inform me.
We finished it.
We have finished this question. All right. Fine. So we have to start with the properties thing. See, there are 4 properties of charges. First property is additive nature of charges. Additive nature of charges means charges are scalar quantities. Now, what is meant by scalar quantities? See, scalar quantities and vector quantities you have already studied in your class 11. Vector quantities have their magnitude, direction, and they obey the vector laws, like your parallelogram laws. While your scalar quantities, they just have the magnitude. So charges also just have the magnitude. Fine. So it means if minus 2 coulomb of charge is present, plus 3 coulomb of charge is present, minus 1 coulomb, minus 2 coulomb, all these charges are present. See, look, this. So when you add all these, directly you can add. Why? Because these are scalar. So net charge is algebraic sum of all the individual charges. That means you can add all the charges. Conservation of charges means charges can neither be created nor be destroyed. They can just be transferred from one body to another. Why? Because the total amount of charge remains constant. All right, the total amount of charge remains constant. Clear? Means, see, if we were having initially, let's say, 3 coulomb here and 4 coulomb here. Now, 1 coulomb of charge has transferred. So this becomes 2 coulomb. This becomes 5 coulomb. Total here also it was 8 coulomb. Total here also it was 8 coulombs. Fine. So this is what is meant by the conservation nature of the charges. Then we have the invariance of charges. Invariance of charges means charges do not depend on the speed. For example, look at this example. There's a body with velocity 5 meter per second. And this is body, and this is the same body which has moved. Now the velocity initially was 5 meter per second. Now the speed has increased to 10 meter per second. Here the charge was 4 microcoulomb. Here the charge will still remain 4 microcoulomb. Basically, because of the increment in the speed, the charges do not increase. All right, because of incrementation in the speed, the charges do not increase. So this is also 4 microcoulomb. This will also remain 4 microcoulomb. Lastly, we have the quantization of charges, which is extremely important. Pay attention on this one. Or do one thing, write down till here. Then I'll discuss the fourth one properly. Fourth property is very important. Now look over here. What is meant by the quantization of charges? See, when there was a single electron present, I have told you the amount of charge which is present in them. That is 1.6 into 10 to the power minus 19. This we have discussed, right? This we have discussed in the last class itself, that the minimum amount of charge that is present in a single electron is 1.6 into 10 to the power minus 19. This is the amount of electrons. Now, if double the electrons are present, means 2 electrons are present, then we have 2 into 1.6 into 10 to the power minus 19 present. Now, if 3 electrons are present, it would be 3 into 1.6 into 10 to the power minus 19 electrons present. Means a single electron is having this much amount of charge. 2 electrons, so 2 times this. 3 electrons, so 3 times this. Fine. So 4 electrons, 4 times this. 5 electrons, 5 times this. N electrons, n number of times this, right? So if we have n number of electrons, we'll be having n into E. So basically this says that charges are integral multiple of E. That is 1.6 into 10 to the power minus 9. And it means n is the number of electrons. N means the number of electrons. So Q is equal to Ne becomes our form. Quickly write down this fourth property. This is the first formula that comes in your exam. written. See, here in this question, basically, Q is equal to NE. Now, what is Q? Q is 1 coulomb of charge. N means the number of charges which are present. And E is 1.6 into 10 to the power minus 19. So when you multiply, when you divide this, see, one more thing I'll tell you, Sufyan and Rafia, that just do not write it as a question. What I wanted to discuss is, remember 1 by 1.6 into 10 to the power minus 19's value as it is. Remember this value as it is. That is 6.25 into 10 to the power 18. Remember this value, because sometimes in the question this is asked directly. 1 by 1.6 into 10 to the power minus 19. This is used in the calculations. So just remember this value, it is better. I hope you have done till here. Nobody updated in the chat column, so I was waiting.
Yes, ma'am.
Let us start with Coulomb's law now. Just update me in the, I think you have completed till now. Let us start with Coulomb's law then. Basically, the force which is present between two charges. Okay, Rafia. See, there is a certain amount of force present between two charges. Just understand this part. There is a single charge present, Q1. This is another charge present, Q2. And the amount of force they are producing, the force which is being generated, force that is being produced, there has to be certain strength for that force, how much the force is being applied, right? That strength's value, this is calculated through a law which we call as the Coulomb's law. We call this as the Coulomb's law. Is this forces of attraction or repulsion between the charges, that amount of strength which is present. Now, what is there are basically 2 points which you have to remember in Coulomb's law. The first point says regarding the magnitude of charges. Basically, you have to take the magnitude of each charge. Now, when we are talking about the term magnitude, what is meant by magnitude? Magnitude means no signs. Fine. Suppose if I say one charge is minus 4 coulomb. So when we are calculating its magnitude, it will be just 4. No units, no signs. If we are talking about, let's say, plus 3 coulomb, magnitude will be just 3. So what is the first step of Coulomb's law? You take the product of magnitude of both the charges. That is Q1's magnitude into Q2's magnitude. This is the first step. So our force that would be generated would be proportional to Q1 into Q2. Second is this separation. Q1 and Q2, they are separated by, let's say, this R distance. This is the separation between the charges. So force is inversely proportional to the square of separation of these charges. Means R is the separation. So square of it would be R square. Force is inversely proportional. So directly proportional to Q1 into Q2 inversely proportional to R square. So once you have it all together, I can say Coulomb's law is directly proportional to Q1 into Q2 by R square, right? Now in mathematics, whenever we are having symbols or whenever we have to remove the signs of proportionality, what do? We remove the proportionality sign by putting an equal to sign with a constant. So K will come K into Q1 by Q2 into R square. So this is the formula of Coulomb's law. Now what is this K? This K stands for one value which is 1 over 4 pi epsilon naught. What is this value? We'll be discussing it. So see, once you substitute this value here, your force becomes Q1 Q2 by 4 pi epsilon naught by R square. Now, what is this K? This is your entire Coulomb's law. So you can use K also. You can use this also. Now, what is this epsilon naught? So basically epsilon naught governs the dependency of the force on a medium. Suppose a medium is present and it is having certain amount of charges. It will be giving you one amount of force. When the charges are present in water, it will give you another amount of force. If it is present in oil, then it will give you another amount of force. So at the end, what will be happening? You will get the net resultant force different in every medium. How is it different? Depends upon this. Look, this K symbol, when you substitute all the values, 4 pi epsilon naught, all these values, you get 9 into 10 to the power 9. This is the value which we substitute. Why? Because you already know what is 4, you already know what is pi, but you do not know what is epsilon naught. This is a new term from this class, 12th class, right? Epsilon. So this governs the dependency of force on a medium. Different types of forces, different types of medium. So different values of forces. Now how? See, for different medium, you have different values of epsilon naught. That's why you are getting different values of forces. Suppose this symbol is just epsilon. This is just epsilon, which is standing for any medium. Just substitute the value of any medium. See, you have this epsilon naught. This is the value particularly for air. And when you put the value for air, you get 8.85 into 10 to the power minus 12 coulomb square per Newton meter square. Basically, this is for air, vacuum, or free space. And this is calculated experimentally. So this value you have to remember. This value, epsilon naught, 8.85 into 10 to the power minus 12, you have to remember, because this value won't be mentioned in your exam. This value is a value you will have to put in and substitute. Now look, if I have a different medium, suppose I have epsilon. Fine, this is for a random medium, any medium. But when I put a naught symbol here, this makes the medium for air. Fine. This is for any medium. This is for air. So if you have any medium, what we have, K we have just studied, this K. This K is also called as the dielectric constant. This is called as the dielectric constant. We'll be studying about this in detail in your next chapter, electric potential and capacitance. There we'll be studying about it. So how to convert, if you just have epsilon present, then what will we do? See, we know the formula through epsilon naught. But if you have epsilon, what you can do, you can put, there's a relation, K epsilon naught is equal to epsilon. K epsilon naught is equal to epsilon. So what you can do, if you are having a formula like F is equal to Q1 Q2 by 4 pi epsilon r square. And we want to replace this because we do not know what's this value. So we can use this formula. So this will be Q1 Q2 by 4 pi K times epsilon naught into r square. This is how we can solve our questions. And remember, whenever you take this ratio, we call this ratio as epsilon r, meaning relative permittivity. So when it's in the ratio form, it is called relative permittivity. When it's just about air, we call it as absolute permittivity. All right, tell me, is it clear till here, both of you, Rafia and Sufyan?
Yes.
All right, write it till here. Any doubts if you have, please let me know. Yes, now we have the properties of Coulomb's law. So this part you have completed. See, firstly, Coulomb's law, this is valid for the point charges or just the spheres. So point charges or sphere means either point-like charges or the spheres which are present. Proper spheres you have or just the point charges. Second is that the distance between the charges should remain constant. Distance remaining constant means we should have either of the charges fixed. See, this is the amount of charges we can have. That is 2 because it is valid for only 2 number of charges. So there is just one case in which one charge can move, which is the charge moving in a circle. See, if both the charges are at rest, both the charges are static, that's the best case. But if one of the charges has to move, other has to remain at rest. If both the charges are moving, that's not a case of electrostatics. It's a case of electrodynamics and your Coulomb's law isn't valid. So one charge would be at the center, second charge should be revolving around it. Next is conservative force. Conservative force and non-conservative force you studied in your class 11. Work, energy, and power. In that chapter, we've studied about conservative forces and non-conservative forces. So the electric force comes under the category of the conservative forces. What are conservative forces? Just for your revision, they are independent of the path traveled. You just have the initial point, you just have the final point, and whatever is the path chosen is ignored. So it's just the conservative force. And last point is that it's a central force. It's a central force means it acts in the line joining between their centers. Please write down the properties. See the two charges which are present. One we have 2 microcoulomb, second one we have minus 3 millicoulombs. Now what we have seen that we take the magnitude of the charge. So first one, since this is plus 2 microcoulomb, we'll be just taking 2 microcoulomb. Plus sign would be ignored here. Similarly here this is minus 3 millicoulomb. So minus sign would be ignored here. So this is just 3 millicoulomb. So when you're calculating the forces between them, you have to convert everything into its SI, standard international unit form. So 2 microcoulomb would become 2 into 10 to the power minus 6 coulombs. And when we take the magnitude of the second charge, this becomes 3 into 10 to the power minus 3 coulombs. Now separation between them, this is separation between them is 3 into 10 to the power minus 3 millicoulombs. So force is K Q1 Q2 divided by R squared. So when you put in the value, you get 6 into 10 to the power 6 Newton. See, K's value is put here, 9 into 10 to the power 9. Q1 is put here, Q2 is put here, and R squared. Write down the solution. See how this question would be solved. Two charges are present, Q1, Q2, which are placed at a separation R. Now they are repelling each other with the force F. So we have the normal case here. What would be the force? The force will be K Q1, Q2 divided by R squared. This is the first case that we have. Now, the second case, the second condition which is given to us, magnitude of both the charges is doubled and the separation is half. So instead of having Q1, this becomes 2Q1. Done, Sufyan. So what's your answer?
I meant to say the question.
How much?
I meant to say the question.
You have not solved the
I've read it
question.
before.
Okay, okay. See, so now what is happening? Yes, Rafia, you're right. It is not force. The complete answer you're saying. See, complete answer, one more term will not just fold. Look how. Because the charges are 2Q1, then second charge is 2Q2. And the separation between them is R by 2. So when you put F dash, this is K. First charge is 2Q1, second charge is 2Q2. And the separation between them is R by 2. So when you square it up, when you square this up, 2Q1, 2Q2 by R by 2 whole square, 2 into 2, this is already 4. So Rafia, which you are answering, this 4 is also present, no? R by 2 whole square. So this 4, 2 square is what? 2 square is 4. So this 4 will go up also, right? So this is the initial case, this is the final case. Now when you see why, because we have the case of R. R by 2 whole square is R square by 4. Now, when you put in the values here, this becomes K into 4 Q1, Q2 by R square, which you have answered, Rafia, correctly. But just this 4 is missing. So when you put in, this becomes 16 K Q1, Q2 by R square. So when you take the ratio of the initial and the final forces, you get 16F as your answer. So this is the ratio, which is the final answer. Write down this, then we'll be studying a little about the dielectric constant. Write down this solution. See, we've already studied about the dielectric constant. So F is equal to K Q1 Q2 by R square. Here I have told you that when you have epsilon naught, it is just for air or vacuum. We talk about the free space which is available. Right? Now, if you have a different medium, we write absolute permittivity of the medium. And for relative permittivity, we have this ratio. So till here we have already discussed. Now, one more thing that I wanted to tell you, K is equal to epsilon by epsilon naught. That's why we substitute K epsilon naught is equal to epsilon. Now, when you have force in air, you just have F is equal to 4 pi K Q1 Q2 by R square. Now, when we are talking about a medium, a different medium, we multiply K times epsilon naught, right? K times epsilon naught we have multiplied. So when you bring this K out here, the rest of the term left is just the force in air. So when you put in the value of the force in air, the ratio becomes force in a medium will be force in air by K. So when we have to write down the formula of the dielectric constant, we write it as F naught by Fm. Means this F naught, whenever you have naught, that stands for air. So this is the force in air. This is the force in a medium. Just make a note point and quickly copy it down. Completed. Sufyan, you also just informed.
Yes, all right.
Now see, this completes with the Coulomb law as well. The electric charges and their concept with the properties are done. Coulomb's law is covered. So we'll be starting with electric field now. So you all can leave the meeting. In the next class, we'll continue.
Thank you, ma'am.